Right, so thank you very much. I'm now going to pass over to the chair for this panel. It's Dr. Helen Bowkett. Helen is the Senior Technical Director of Arcadis and visiting professor at the University of West of England, Centre for Transport Society. So over to you, Helen.
Thank you, Brian. It really is a great pleasure to be able to introduce to you three really good speakers who got doing some really interesting work in the area of agent-based modelling. So as we've just got an hour today, what we'll do is each of these three speakers, Liz, Ed and Nick from UCL and Leeds, will each speak for 10 minutes and then we'll have a panel discussion and take questions at the end. So first of all, I'd like to introduce Liz Varga at UCL and she'll start her talk now. Thanks, Liz.
Thanks, Helen. It's a pleasure to be here. Thank you very much for the invitation. And I'm just going to share my screen. And if someone could confirm that it's showing okay.
Yes, perfect. Thank you, Liz.
Okay, thank you very much. Okay, so my name's Liz Varga. I'm a professor of complex systems and I run the Infrastructure Systems Institute at UCL. So, as I said, pleasure to be here. I'm going to talk about agent-based modelling with an infrastructure focus. And indeed, I think it's quite useful to understand what infrastructure systems are like compared to other systems. And this work by Marcard, sorry, I've gone on too far. This work by Marcard has tried to identify some of the key characteristics of infrastructure systems. So you can see that across all of the different key economic sectors of electricity, gas, water, sanitation, transport and telecoms, that we have high capital intensity and high asset durability for all of these assets. And indeed, regulation intensity and systemness, which is another word for interconnectedness or interdependency, is also high or very high, except for road transport. The sort of role of public organisations is different across different sectors. And even that in itself is interesting with the sort of very minimal regulation in telecoms, but actually very heavy regulation in water and railway and sanitation. So infrastructure is different from other systems. Now it's also important to think of infrastructure scale. And if you look at the right-hand side of this table, you see that infrastructure is actually thought of as a mega scale, mega system. And it's usually the linear networks that go across the country, our transport networks, information highways, and so on. But actually, when we define infrastructure systems, we don't think of just the linear network itself. It's also that set of assets, technologies, organizations that enable the whole infrastructure system to work. So they include all the decentralized and very local aspects of an infrastructure, not just the network itself. And just to say that infrastructure is not isolated in an engineering faculty. Indeed, at UCL, we find infrastructure in all of our faculties. And it's an ongoing work from my perspective in terms of identifying what people are doing in different disciplines and faculties related to infrastructure so that we can better connect and understand the whole system of system that is infrastructure. Now, so importantly, infrastructure provides a critical service because society and business, the economy depends on it. So it's a really important service. And I would say that there are three key priorities in infrastructure. The first is safety, and probably now safety too, which is also synonymous with engineering resilience. So how can we keep our systems safe for the users and participants and operators, but also resilient to different hazards and interruptions. The second priority then is sustainable innovation. How do we continue to innovate, but also do it with sustainability of the environment in mind so that we don't create any worse conditions than previous generations have done? And then thirdly, how to be efficient. So this continuous program of improvement so that it's better value for money, but also efficient and inclusive, I would say, accessible. We have 4 strong enablers for infrastructure systems. The first is Industry 4.0, broadly digitalization, but that set of technologies, algorithms that enable us to not only write the models, but actually enable infrastructure systems themselves to be innovated. Decentralization, where we can make local decisions which can help the entire system improve. And you've heard of prosumers and other decentralized technologies where we can have consumption and production locally as well as connected to the networks. Democratization, this ability for everyone to have access if they need it. And of course, that's very important with things like rural telecoms, so that people can get onto the internet. And of course, decarbonisation, which goes as a mandatory effort these days. So I just want to cover these three priorities in a bit more detail, because what I want to show is that those priorities can be addressed by agent-based modelling. So just so that we understand what the priorities are and what's being done in the fields at the moment. So for engineering resilience, the National Infrastructure Commission has written recommendations for regulatory intervention, and the report's called Anticipate, React, Recover. You can find it on the internet. Colleagues at Sheffield University have led this paper of mine that was on the resilience wheel, showing that resilience has different objectives, states, functions, and so on at different stages of a resilience event. So whether it's the long before, the during, the after, or the long after an event. So the focus needs to be different, so our models need to be different. And then the Royal Academy of Engineering, sponsored by Lloyd's Register Foundation, their work on safer complex systems, part of their Engineering X project, is also looking at how we can have safer and more resilient engineered systems. So a tremendous amount of intellectual property going into the idea of engineering resilience that we need to develop with agent-based models. For sustainable innovation, the Dasgupta review is, I think, already out to consultation, not yet finalised. It's a review of the economics of biodiversity, so making sure that when we invest and develop our infrastructure systems, that we're mindful of the biodiversity of the environments that we want to implement into. Of course, the Conference of the Parties, which is part of the United Nations Framework Convention on Climate Change. Of course, their meeting was cancelled this year due to COVID, and there's a little graphic of the COVID virus, but it will be held, a physical event next year in Glasgow. Of course, a massive global effort to make sure that we innovate sustainably. And then the Infrastructure Projects Authority, their annual reports on major project investment. And of course, these are the ones that are needing to be especially mindful of the effects of innovation so that they are sustainable. All of these are opportunities for agent-based models to come to the fore. And just in terms of efficiency, of course, we have all the sector regulators making sure that we have good value for money, that there is inclusive access. But actually, we also have business push towards efficiencies, not just from individual organisations, but if you like, projects like circular economy, which are trying to show that you can do sustainable innovation because it's good not just for the environment, but it's also good for business, because there are new business models that are enabling us to be efficient. Now, so if we have these three priorities, what I want to try and do is show that we can solve all these three priorities with agent-based models. And what I'd like to think about is what types of agent-based model we have. And the three are formulated are based on time. So this idea of the ex-ante agent-based model, which is essentially future-looking, it tries to probabilistically evaluate what the performance of a system might be like in the future. We generally do this by establishing scenarios, but what we do in those models is to see what interventions we can make and what effects they might have, based on assumptions, of course, and agent-based modelling allows us to specify these very clearly. Another class of model is the real-time model, and we see this particularly in things like urban observatories, where we're already monitoring systems so that we can, if we detect something's going wrong, we can actuate containment of disaster escalation. We can use high-speed computing and a lot of the Industry 4.0 technologies. And of course, digital twins are coming into the fore. And one of the questions for me is, how can digital twins work with agent-based models going forward? And then the third class of temporal model is the ex post model, which is looking at how did the system actually perform? So it's a retrospective evaluation, usually for learning. And so we need to know how we did on sustainable innovation, how we did on efficiency. So it's a look back, but useful for future change. Of course, all three classes of model help with the priorities in infrastructure. So a quick example from each of these in agent-based models. Of course, for the ex-ante model, we're trying to find the best chance for desired outcome. The boundary for our model can include social, environmental, and economic domains as we need to, depending on the scope of our model. And a very nice example of the sort of ex-ante model is in this Nature Climate Change paper. An ex-post ABM model, we're trying to see, did the system and intervention achieve the desired outcomes? The boundary of the model is defined by the evaluation boundary. And an example here at a congress actually, and the title a bit misleading, it says innovation policy assessment, but actually it means evaluation. And again, a system of systems, highlighting this ability to look at across social, environmental and economic systems. And then finally, real-time models to help us detect, anticipate, possibly even self-heal. And I want to raise the work at the Centre for Digital Built Britain, this National Digital Twin Programme, who are looking at how we can use real-time data, but also UK, so UCRIC, which is the United Kingdom Collaboratorium for Research and Infrastructure in Cities, and the Data Analytics Facility for National Infrastructure. I can provide links if people want to find, but you should be able to find these on the internet, all trying to see if we can do things in real time. So my last slide, really, I want to make the point that ABM is not the only solution. It's one of the best solutions. And for me, it's like almost the best sweet in the sweet shop, if you like. But we have to find the right tool for the problem we're trying to solve. So it's purpose-driven, our selection of tool. And some of the work I've been doing with CCAN on evaluation of complex systems, particularly by Barbara Bafani, has identified a number of tools useful for evaluation. ABM is in the list and often scores very highly, but there's an array of tools that we could possibly use. So that's it from me, Barbara. Thank you very much. Sorry, Helen.
Don't worry, any name will do. My children will tell you that. Thank you very much for that, Liz. And I just want to remind everybody that all the videos are being recorded and they're going to be put up on the Catapult's website in a few days. So there's a lot of really useful references and places to go to follow up there. So if you didn't get them all down, don't worry, they'll be on the slides. So I'm now going to hand you over to Ed Manley, who was at UCL, has now been up at Leeds for about a year or so now. So thank you, Ed.
I fit between the UCL speaker and the Leeds speaker as a person in between, so I sort of bridge the two. So happy to do that. Right, okay, let me see on my screen. Okay, presumably someone will tell me if they can't see that. Right, I'm going to talk about agent-based models for infrastructure from a slightly different perspective, and that's the perspective of modeling behavior. I suppose I think the promise of ABMs lies in its ability to represent choice and behaviours in all of its heterogeneity, aligned to observations from data sets, and to make explicit the communication and interactions between agents that are informed by an agent's environment and their own personal perceptions. And this leads to naturally the bits I'm interested in, which are these patterns that emerge over space and time that are dependent on those spaces and the times that the events take place. And I mean, one of the attractions is it's a generic, flexible framework. It doesn't need to align to any established silos, and so allows you to sort of look at problems quite without restrictions, in a sense. So in terms of investments for infrastructure, I think it can allow us to start unpicking some of the assumptions around behaviours that lead to macroscopic processes, and start looking at, and I think this is something that Andy Haldane mentioned earlier, look at how multiple systems interact or influence behaviors and lead to the emergence of these patterns over space and time. And so there are three areas I just wanted to sort of highlight very quickly, just bits of work that I've sort of been putting together over the years around ways in which ABM can be used and developed further to maximize its benefits as a modeling platform. So let's jump straight into them. And the first one is around just its ability to question and help us understand the assumptions that underpin conventional models and build new models that bring in thinking from diverse disciplines. I think too many models, too many established modeling frameworks aren't fully questioned or their assumptions are explored. So an example with this would be something like a traffic model, which is modeled here. On the top left, you've got the traffic flow that would emerge if all of these agents going from fixed origins to destinations picked the shortest path according to distance, using their perfect knowledge of the road network. So they know every single road in the road network. They're like a black cab driver in that sense. And the others show how that traffic flow, so the emergent pattern would change if you just changed the behaviors of those drivers very simply. And the driver in each case, so minimizing time, minimizing their angular deviation, or limiting the amount of knowledge of the road network they have, so they don't know the smaller roads, which is also realistic. All of these different ways you might model are quite simple, but they're all based in different ways of thinking. And so ABM allows us to draw in different ways of thinking, draw in different ways of modeling behavior within the same framework and make these comparisons about how different assumptions lead to different outcomes. In this case, you know, the sort of the end of that kind of way of thinking is something like this I propose, which is a very complex navigation model. Now, perhaps we can think about how complex we want to go, but this modeling framework, for example, you know, it ignores that assumption of perfect knowledge and human optimization, and brings in thinking from neuroscience and psychology into the modeling process. And I think that sort of thing is certainly very possible with ABM. The second aspect I wanted to highlight was just the ability of data to be used in our models to model heterogeneity. I'm particularly interested in this case in where choices are changing because of disruption and major events. So something like this data set, so this was an analysis using Oyster card data from Transport for London. Using that masses of data, we can establish regular patterns of behavior on millions of individual travelers. So we can see when they usually take the tube or the bus, when and where, and how that distribution looks for every individual. Once we have that understanding, once we have that underpinning of what normal looks like for that individual, we can then start modeling how their behavior changes under different types of disruption. And one thing we're looking at now is whether that behavior, you know, whether different choice modeling architectures are better for modeling disruption and change relative to, you know, your standard discrete choice or optimization function. So yeah, I think the indications are that, and the intuition from all of us would be that they certainly are. There certainly are different things going on when you are disrupted, when your tube line goes down or there's a major traffic jam. But we don't fully understand that yet, and I think ABM allows us an opportunity to really explore that. In a similar way, we can use sort of established data sets like surveys. So this is the British Social Attitude Survey to explore in more detail some of the more cultural aspects influencing people's behaviours. So in this case, we look at using cultural theory to see how it affects people's mobility attitudes. So whether they're more willing to reduce air car travel, cycle, etc., and how that plays into a model, into the future, which could allow us to get towards sustainable mobility transitions. And again, this is just really disaggregating the model process, the behavioral process, to really start drawing out aspects of people's backgrounds and cultures. And the final aspect to touch on is how we can also use ABM as a platform for testing new modeling approaches. And in this case, I'm looking at reinforcement learning, which we're increasingly hearing about from a Google DeepMind point of view. They're modeling agents in incredible detail with incredible sets of inputs and managing to create some very complicated, very sophisticated models of behavior. ABM would allow us to actually start unpicking or start integrating some of these modeling approaches into models of infrastructure. And I think some of the constraints relating to computation are reducing so far. This is very early work, but I won't go into explaining it, but I think I just want to highlight the potential of different modeling approaches. So how do we overcome these barriers? How do we sort of chart a path forward? For me, it's about identifying the use cases and really exploiting the use cases that best suit ABM. And these are the ones where, for me, a disruption, perhaps a pandemic, but where there's recognition that there's a need to overcome the inertia associated with conventional approaches. I think there's also an opportunity to use ABM as a platform for multidisciplinary collaboration. So how do, I'm very interested to consider how do the traffic flows get influenced by changing work patterns, or changing attitudes towards sustainability, or changing health factors and demographic factors. I think the ABM is a platform for allowing us to really get into those heterogeneities. And I think we need to make full use of data and new modeling approaches to really capture these and look at the variation of space and time, and think creatively going forward about what the bigger impacts are going to be on infrastructure in the long term. We're going to see massive array of influences into the future, just very, very hard to unpick. So we need to think creatively and think about new ways of doing things. Finally, the other thing you can do is read a book. For example, this one, written with my colleagues Alison Hempstall and Nick Mallison, about learn how to start modelling these things and start using the very excellent tools that are out there already. So that's me. Thank you very much. I'll stop here.
Thank you, Ed. That was really interesting, and loads of thoughts at the end, which hopefully we can pick up again in the panel discussion. And just to let you know, I had encouraged Ed to plug his book. It's well worth a read. So I'm going to pass on now to Nick Mallison, who's at Leeds, for the final talk before we move into the panel discussion. Thank you, Nick.
Thank you, Helen. Sorry, I'm just setting this so that I know when to stop. That sounds like a brilliant book. I mean, I'm going to go and buy a copy myself, Ed. I think it sounds like something everyone should do immediately. The hard version is probably even better. In case it's not clear, I'm a co-author, but don't let that change your mind. I think everyone, can you see those slides? Sorry that there's an address bar in them. I couldn't get rid of it. Right, thank you for inviting me to this panel. What I'm going to talk about today is I'm going to focus more specifically on how we can do some real-time agent-based modeling. So this is something that's come up a few times in the talks throughout the day, and it feeds kind of really nicely to some of the work that we're doing in Leeds. This is a presentation that I've put together with my colleague Alison Hempstall, and lots of other people at Leeds who haven't been referenced properly, so I apologise to them. So what's the context of the problem that we're trying to solve. If you think about somewhere like Trafalgar Square, we can make some quite good models of what's happening in Trafalgar Square. So for example, we've got quite good data on who lives there from the censuses and other surveys. We've probably got good records from hotels. So we can build up quite a nice model of who lives in Trafalgar Square and other busy urban areas like that. But we will struggle to find information about what people actually do when they get there. So why do people go to Trafalgar Square? What do they do? Where do they go afterwards? So we've got very much less understanding about the dynamic or the ambient population in areas like that. This makes it difficult for us to understand things like crime rates, because we don't know what the population at risk is. We don't know who's being exposed to pollution. So there may be a lot of pollution, but are there lots of people being exposed as well? Councils and cities are very interested in attracting people to their city centres and keeping them there to spend money, and this has become even more pertinent with COVID. But again, how do we actually know what's happening? How can we encourage more people into city centres? And then obviously, if we're looking at things like disease spread, it's possible that busy public spaces are more at risk than quieter public spaces. So a good model of the ambient population would be really useful. The other thing that we need to think about is our traditional data might be becoming very out of date. So I took that video of Trafalgar Square a couple of years ago in the summer, and then I went back over the school holidays this summer and took another video on a busy day during the school holidays, and obviously there's very few people there as a result of COVID-19. And there's lots of data for people not visiting city centres nearly as much. So the point being that if you're basing your models on data that are months old, they may well be out of date, and the models that we might be creating may well be a very poor representation of what's actually happening now in cities. So what we're proposing to do is use agent-based modeling as a way of trying to bring together lots of different data sets, some old and partially out of date, some newer ones that they're messier but may also be useful. And can we bring them all together in a model? So could we simulate people going about their daily business and then feed in information from traffic counters or social media contributions or cameras that count passers-by, anything like that, that gives us a much better up-to-date set of data about how many people are visiting cities. So that's what we would like to do. But there's a big problem in that, and then it's very hard to actually feed data into agent-based models. If you think about a model of a flock, for example, we might have excellent information about where the flock of birds starts, and we might have really good behavioral models for these birds. We know kind of roughly why they make the decisions that they do when they're flocking and how the flocks form. If we set up a model and a model of that flock within seconds or minutes, if we're very lucky, the flock and the simulation will have diverged entirely. So our simulation of a flock might still look very good. It might look like a flock, but it's not going to look anything like the real flock of birds, which is going to be the same thing will happen if we're trying to model other complex systems like people moving around cities. Fortunately, there are methods that we can use to try and get around this problem. Data assimilation, for example, is something that the Met Office or the meteorologists have been using for decades now, and it's one of the reasons that weather predictions have got so good. So there's decades of good mathematical work into how to feed data into models in real time. And what we'd like to do is adapt some of those so that we can try and feed real-time information into our agent-based models and then inform policy much quicker. Okay, so where we'd like to get to, and don't get me wrong, we're not anywhere close to being here yet, is we could have our agent-based model running. So it's trying to simulate what synthetic people might be doing. When we get some recent information, we can feed that into the model. We can adjust the state of the model. So we may be simulating one area quite poorly, so we may increase the population density in that area, run the model again from that point, and any forecasts we make from that point should be that much better because we've had up-to-date data. This is the way that things like weather models work, for example. So that's where we're trying to get to, but it's very difficult. So there are big methodological challenges in that the methods that have been designed work very well on continuous surfaces. They don't seem to work very well, or at least we haven't been able to get them to work very well on agent-based models yet. So there's a lot of methodological work that we need to do. And there's also lots of work we need to around collecting the different types of data that are appropriate to model the kinds of systems that we want to model, and data that are ethical. And I'll come on to those issues at the end, but what I want to do before moving on, just very briefly, is give you an example of a piece of work that we're actually doing at the moment to kind of put some flesh on the bones. So this is a data set of people moving around in Grand Central Station in New York. It was collected, I think, 15 years ago or so, and it's available online. People have written papers about it. Here are some references. So we've got here this really good data set. We could build an agent-based model of people moving around this train station, and then we could try and feed data into it. And because we can actually see all of the individuals who pass through Grand Central Station, because we've got their trajectories, we know exactly how well our model is doing. In reality, we wouldn't want to track people, so we wouldn't have this truth data. So this is a really nice data set to train our models on. So what we've done is we're using something called a particle filter, which is one of many data assimilation methods, which I won't go into because of time. And what the model does is it tries to simulate a number of different realizations of that system. And then each time you get a new data set, it works out which of those realizations is good, which are bad, and the bad ones it throws away and it keeps the good ones, basically. This diagram shows, imagine that's a crowd of people moving from left to right. We can only see 2 individuals there, but imagine you can see many. They'll all be interacting. And those little red dots show where our models think those 2 people are. So the 2 black squares are hypothetical people, the little red dots are simulations of those people. And what you'll see is as the model moves along, the little red dots start to spread out. And that's because with uncertainty in how people move around, there's the estimates of where the people are become less certain over time. So you'll see them spread out. And then here we do some data assimilation, and the red dots, the ones that are simulating the positions of those people very poorly, will be sampled out. So actually it looks like they're all coming back together and making a good simulation. So once you've done your update step and you've assimilated data into that model, you then have a much better representation of what reality would be like. Now, of course, if we were doing this in real life, we wouldn't see those black squares. We wouldn't know exactly where the people were. We would just be trying to estimate it using something like this. Okay, I think I will move on through the results in the interests of time. One of the problems that we're facing, which I think is really interesting, is that the model breaks down when people don't walk in roughly straight lines. Okay, and I know this, it sounds obvious, but if you enter a train station and you start walking across in one direction, our model can pretty quickly pick up on where you're heading. So the red line there and the orange line are both fairly easy trajectories to model. What happened with the blue line is, though, the person started heading to the southeast corner, they went to the ticket booth in the middle, don't know what they did there, probably bought a ticket, maybe asked for some information. They then headed down to the southwest corner. So our models were all kind of tuned into thinking that they were heading one way, but then it turned out they headed the other way. And it's very difficult to manage that kind of situation, which I don't think is a similar problem that you would get in some of the physical sciences. Here are some other methods you could use. So just to finish up on the ethical implications, with all of this work, we need to be really careful about data biases. Some data sets will probably be pretty robust. So in Leeds, we have cameras that count the number of people who go past them. So it's an anonymous data source. I'm pretty happy that the algorithms they're using aren't biased towards counting different demographics, for example. So if you do something like that, you should get a pretty reasonable estimate of how many people are passing a point. But if we were using something like social media or people's mobile phone use or anything like that, there are obviously going to be very serious biases in those data sets, which you have to be much more careful for. We also don't want to track people, so I don't want to propose that we develop methods that can allow us to, monitor someone as they move through King's Cross Station and try and build simulations of that. So all of the work that we're doing is designed to work with aggregate methods. So these are just anonymous counts of people that we're trying to calibrate our models on. Final slide is where we're trying to go with all of this. Ultimately, we'd like to make digital twins of human systems. And this is something that Liz talked about earlier. So if we've got this big model, can we feed data into it in real time and then make a better estimate of what's going to happen in the city in the short term, at least? And there's lots of work in this area, less so in the agent-based modeling side. So that's where we're focusing on. And I will leave it there just under 10 minutes.
Thank you very much, Nick. Yeah, another interesting, thought-provoking talk. Just to introduce myself, where I come into this debate is I've spent all of my working life providing evidence to present to decision makers and policy makers in the transport world to assist them in making decisions about things like transport infrastructure investment, transport policy making. So when I come to write a paper to present evidence to them, often I have to use models because I'm trying to predict the future and say, if you do this in 10 years' time, then I think this will happen. So frequently I'm using models, and I like to think about all these different modelling approaches that are out there as different tools in the toolbox. And it's part of my job description to select the best tool for me to use to provide robust evidence to the decision and policy makers. So I like the comment that Liz made, that she felt that ABM was often the best sweet in the sweetie shop. I'd like to say tool in the toolbox. So a question I'd like to put to the panel to start with for discussion is this tool still just a prototype, or is it usable? And how are we going to sort of, your thoughts on managing this transition from prototype to usable? I'm a bit concerned about the possibility that a policymaker might say, oh, I saw an ABM once and it was rubbish. And we sort of need to separate the methodology from the different models. So I was just wondering, from your experience and background, if you had any thoughts or comments about how we manage this transition into maturity of an ABM approach to modelling. Do we got like any hands up who might like to go first?
Yeah, I can Helen, yeah. Yeah, so personally, I don't see ABMs as still in a prototype stage. I see that they aren't as diffused into practice as I might have expected. So if someone had asked me 10 years ago, what would be the main tool that policymakers were using, I'd have said agent-based modelling. But I haven't seen it implemented as much. People have written about why not? And I think one of the chat questions is actually about validation. And in fact, that still continues to be a challenge, especially when we're looking at ex-ante insights, is how can we validate something that hasn't even happened yet? But I would say one of the biggest challenges is that we have quite a broad range of tools actually for agent-based modelling, to the, if you like, very abstract platforms like NetLogo, which let you model things like, like the flying, the flocking behavior with like simple rules that can be really insightful, but not very relevant to actual practice decisions. Whereas we can have, on the other hand, very, very complex models about real world systems that can be so inclusive. Actually, it's a challenge to understand the logic and actually for it to be transparent to decision makers. So there is this very broad spectrum, and we don't seem to have solved the problem of which model for which purpose, and to improve the characteristics of each of those models enough for people to have confidence in them. I think that's enough.
Ed or Nick, do either of you like to come into the conversation on that point?
Go on, do you look like we were about to start?
Okay, I'll go first. Yeah, no, I think we're probably lacking a bit of a visual identity for ABM in a sense of what are the best tools to work with, because as Liz says, I mean, Logo is great for demonstrating some of the concepts, but not really great for fully implementing policy. Well, maybe people disagree with me there actually on that point. And I think there probably is a bit of a sort of credibility issue there. There are definitely tools which are emerging. AnyLogic is one that springs to mind, where people are trying to sort of develop something which is a bit more commercially focused. But yeah, perhaps it just sort of is something about something's going to come with time as the interest comes from commercial sector. You're starting to see academic projects becoming a little bit more serious, bit better maintained. I'm thinking about MATSIM, for example, in transport, which is, going from something which was quite sort of academically focused about 5 to 10 years ago, but to now something which is being used increasingly in practice across different sectors. As a generic framework, I'm not sure we'll get to an approach where there's going to be something which is perfect for everyone.
I don't actually have anything to add, Helen. If you were waiting for me, I mean, they've summed that up really well, I think.
Okay, that's fine. I think one thing where ABMs can be useful is pointing out mechanisms at work that policymakers hadn't realised before. So I think we'll go on next to tackle the question about validation that's come up. But sometimes a model doesn't have to be fully validated in order to be useful. I remember once producing an ABM model that sort of showed that even if you were giving old people bus passes, it didn't stop the vicious decline in bus use in Wales. It just slowed it down, but it still sunk to a pretty low state. And it didn't have to be exactly correct in predicting how many people would be on the X bus in the future, but it showed how mechanisms at work would play out unless there was an intervention. So maybe that actually, perhaps that's a leading way into this question that has come up about how do we deal with validating ABMs? Because I know that's a common criticism of them, that they're not easy to validate. So how can you know if they're truthfully replicating the system you're trying to model? Anyone want to follow? I'll read out the question that has come through. It says from the audience, since the comparison between a complex simulation and complex data is highly multi-dimensional, especially with geographical systems, how does one know when validation is good enough? Now over to you, Liz, as you had your hand up.
Yeah, thanks, Helen. Yeah, so I've come to the question you've just set at the end, but I think, so we're writing a paper at UCL on model validation, and what we've done is included a multidisciplinary group. So we have people who favour mathematical models, people who favour system dynamics models, and so on. And what we wanted to do was to come to some shared understanding about what the criteria were for validation. So this is work in progress. Hopefully you'll see it published sometime next year. So I can give you the 7 characteristics for model validation, if you like, the 7 criteria for have you validated. And the first one is internal model consistency. And this is about the logic inside the model. So regardless of the application, is the logic, is the internal consistency valid? And you can test that with different mechanisms. The second one is the realism of the mechanisms. So are the things we're describing actually, could they exist in the real world? So it's almost like a sanity check. The third one is about model robustness. Will it fall over if it encounters some outlier or some random condition? Could we rely on the model still performing and giving us a sensible answer? The next one is model transparency, and I think that's perhaps one we need to work at more with ABM. So how can we make ABM more explainable, just like some of the AI explainability research is happening just now? The fifth one is about relevance. So this is very much about stakeholder engagement in actually the description of the system we're modelling and the interventions that are being modelled. So how can we increase that stakeholder engagement as part of the process of an ABM model? The sixth one is external output validation. So if we have got some empirical data, then can we replicate what's happened in the real world with those same conditions? So is there some matching we can do to say we're within 95% sensitivity, it looks like what the real world would do? And then the last one is about model confidence. And this is about the other characteristics of an ABM, like who wrote it, what track record have they got, and so on, which is really important when you don't have some empirical data to test it against. And so things like the MatSim, which was very academic before, which has become more, people have built their confidence because it's been used more and made more relevant, even though at the beginning we might not have been sure. But now that the group's established and it's being used, we have got a lot of confidence, and probably in new ones, new ABMs that they'll create. So back to the question, which was about was it about, or has that been answered?
It's about validation of models, particularly geographical models, which they've got lots of multi-dimensions to them. Yeah,
so with geographical systems, obviously these are more spatial models, if you like, more like a simulation rather than a sort of generic type of model, which is not necessarily space and time limited. So with those geographical based models, it very much depends on the assumptions that we put into the model. And whenever we model, we always simplify. So are the assumptions we've used for that particular geographical space the right ones? So it's about, I think, transparency, and also about the changing landscape. So how long will the model remain valid if you've fixed it to that particular geographical landscape? Because landscapes change, as we know, for all sorts of reasons, like road systems get changed and just new systems, infrastructure systems are built. So I think it's about the transparency of what that model, what the assumptions were for that model, and how, and knowing that things have changed and therefore the model's less relevant.
Thanks, Liz. Does anyone else like to come into that? Nick?
Yeah, thanks. So my thoughts are, I'll talk about the question specifically in a second, but I think for some models, validation isn't necessary. So if you've got almost a thought piece as an agent-based model, and you are showing that under some conditions, some kind of regularity arises out of those behaviors, then it almost doesn't matter whether or not that's validated. That can tell us something interesting about the way this simulated system works. That may or may not be relevant in the real world, but I think having that new knowledge in itself could be valuable. It may be that it doesn't have any relevance to the real world anyway, but the fact that you've learned something new about how different things interact and what emerges out of that could be useful. But for models where we are making predictions of the real world, then they obviously will need to be validated to some extent. This is something that's particularly challenging in modeling cities because there are so many different, because it's such a high dimensional model and such a high dimensional system that there will be many different models that can fit the observations that we have. I think the way that we're going to try and come at this is collecting data on many different levels. So you could have individual, you could monitor individual places and collect data from them. You can also have your daily aggregate data on people's kind of daily patterns. And if you collect enough data at enough different levels, hopefully you reduce the number of models that are plausible. So you only end up with a set that look sensible. So it's certainly not, the question says, how do you know when validation is good enough? Do you ever know when it's good enough? But I think we can, by doing validation rigorously and using large amounts of data sensibly, we can probably get to a point where we can be reasonably confident in our results. I know that's not the kind of thing a policymaker wants to hear, do they? They want a yes or a no, but maybe that isn't the right thing to tell them anyway.
Yeah. Ed, do you want to come in there? Or?
I think they both the speakers made great points there. I think the only thing I would possibly add is that the new forms of data allow us to sophisticated and quite detailed agent-based models of behaviour, but these should be validated against independent data sources too, as Nick's sort of saying, collecting at different scales to ensure that the data sets we're using are representative of the model.
Yeah, another challenge I've come across is in transport. There's a conventional way of modelling transport using the 4-step models, and people want to use the validation criteria from those models and then apply them to ABMs. I think that's something we've got to be aware of. It's sort of, in a way, educating people this is a new modelling approach, and maybe we need to develop different modelling criteria. I'm going down with, I've got fog in my throat here, so I'll move on to the next question, which is how we can justify our model results if we don't have data and there's so much uncertainty in the world. So anyone like to pick up on that while I try and clear my throat?
Oh, sorry, Liz, were you?
No, go for it, Nick.
No, I think it sort of follows on from the previous question, doesn't it? That it's not black and white. There is going to be a lot of uncertainty. Presumably you must have some data, otherwise, where would you start? Even if that's theoretical studies to give you some information about what you're trying to model. But again, I think you need to do what you can, can't you? You slowly build up an evidence base and you build up your models, and hopefully you get to a point where you can have confidence. And it's not like you can set a bar for saying at this point I'm confident and at this point I'm not. It's just a matter of doing what you can. I'm sorry, that's not a very good answer.
And to some extent, that is one of the advantages of ABM, is that they're not static models, they're dynamic. Mm. So actually you'd expect to see a lot of variation in your output. And so actually you're wanting to validate things in a different way. So maybe the model is reflecting uncertainty that actually does exist there in the world that we're trying to model. We've had another question that's come in about messy systems. The question is, I'd like to ask the panel about their experience with messy systems or wicked problems in relation to ABM. And I just wondered if you've got any comments on that. I mean, I think part of it picks up, Liz, what you're saying, that models are simplifications, and part of the art of modelling is how do you simplify or get to grips with a wicked problem to be able to transform it into something you can model. I wonder if you'd like to sort of follow up on that.
Yeah, no, so I agree. And I suppose that's the almost like beauty of agent-based modelling, is that it allows you to include aspects from multiple domains. So we can include, you know, the social behaviours and the randomness of what people do, as well as the sort of randomness of markets, as well as the environmental, non-linearities. So all of those can be accounted for and are all wicked problems. It's not to say that the agent-based model is going to tell you the truth, because there are probably multiple truths out there to be discovered, and we don't yet know what the truth will be going forward. So, but it's a way to explore the space of what a truth could be. And the more you iterate the model, this is why we run agent-based models, you know, tens, thousands of times, so that we get some sort of confidence interval that, you know, 95% of the time, this is likely what will happen. And that can give policymakers an absolute steer in terms of the majority. But I think for me, it's about those ex-ante models need to be continuously refined with new data, so that that interval can be adjusted based on what people are now doing. So you get that continuous refresh. And that's why moving these ex-ante models towards real time, even if not exactly real time, is going to so help with getting confidence into policy making about what the model is telling you.
Yeah, I think just follow that. I think there's an aspect here about trying to explore the variety of inputs or interactions that might lead to a set of different types of outcomes. So I'm just thinking about the project we've done on cultures and how they've underpinned people's mobility choices. There's a number of things that might happen there. So you could imagine a future, a variety of set of futures where there's no change or no deviation towards sustainable transport modes. But, you know, obviously, there's another end of the spectrum where everyone is now cycling and no one's taking cars, and we've got car-free cities. But there's a set of scenarios in between, and it's about identifying the key factors in the model that lead to different outcomes. So it may be demographic change, it may be accessibility changes, it may be policy or legal interventions. But what is the combination that leads to a specific set of scenarios? And I think if you can communicate that cause and effect in a way that is sort of easy to understand, then I think that can help people get on board with the potential for ABM for influencing policy and long-term policy.
We've had a question come in to say whether the Department of Transport should change their guidance to allow us to submit output out of agent-based models. And I'm raising the question because I think that's a quite interesting idea, that actually maybe the decision makers and policy makers need to learn about these new models and be open to accepting evidence from them. And I wonder how we can approach sort of educating the recipients of our modelling advice. Any comments on that?
I just want to be very quick. I mean, I think that we're all three academics. I think there is a commercial responsibility here, and I think it's happening in terms of transport and tag, and you know, people at DFT are recognizing the potential for transport. COVID, you know, there's a variety of different consultancies who are working on ABMs using Maxim. So I think there is a certain interest in this, and we're talking about it as well. But it's not just about academics. It's about external agencies and companies, you know, taking a leap in that sense and trying to push for change and do something different. A lot of people recognise problems with the 4-step model as a specific example, and I think that's probably a case across lots of different sectors.
I think it's absolutely a challenge, but I think that there are a number of individuals in these central government departments that are helping towards it, and certainly adopting and championing even the arrival of agent-based models. One of the challenges is that they obviously take a little bit more investment than something, if you like, an amateur, for want of a better word, modeler could do, because there's a lot of judgment that's made in the creation and the development of an agent-based model, which you may not need so much for other tools in the toolbox. And obviously that intellectual decision-making needs to be rewarded. And this is the point of, you need that commercial aspect to it as well, which also leads to the challenge of how open can it be if it is a commercial venture. Whereas we want all our models to be transparent, and in fact they are. If we have government funding, one of the research councils, then they are uploaded to GitHub or one of these other platforms, Open ABM, that people can see what's in the model and they can use it again and so on. But when a government department has put money into it, then it might not be so freely accessible because of contracts with suppliers. It also begs the question of, can it be truly believed because it's not visible, because you don't have that transparency of it. And in fact, sometimes you don't want the model to be revealed because it might expose aspects of a system that needs to be secure. So obviously, not just for cybersecurity, but actually for physical security of our infrastructure systems, there's a really good case for not sharing. But that needn't be the case for everything. And it's this thing of, we can use the security argument, we shouldn't share, but actually that shouldn't be, it should be sharing by default, and let's agree when not to share, subject to commercial implications.
I think we'll end on that point. Let's share by default. I'm going to hand over to Brian if he wishes to bring the panel discussion to an end, but thank you all very much.
Thank you all. For some reason, my camera suddenly made me look exceptionally large. So apologies for that. I just want to say a big thank you to Helen, to Ed, to Liz, and to Nick for your very excellent contributions. As I said to other panelists, this has been a very long time in coming. It's certainly been worth the wait, and I've been very grateful and informed on the discussion. So my thanks again. Just to let delegates know that we do have 2 more panels later on today on natural environment and health and social policy. All the panels are being recorded and will be made available on our Digital Catapult YouTube channel in the next few days. So feel free to come back and watch again at your leisure. Thanks again for everybody that submitted questions, and for the panelists for their very concise and excellent answers. On that point, it's dead on 1:30. Thank you very much all again. I hope to see a number of the delegates in our 3rd panel this afternoon, which is at 2:30 on natural environment. So panelists, thank you very much again, and I hope to speak to you very, very soon. Okay, you take care. Bye.